Today I am going to discuss the treatment of restaurant grease, oil and fat, FOG, wastewater. The treatment of restaurant grease, oil and fat, FOG, wastewater is essential for preventing blockages in plumbing, environmental contamination, and ensuring proper wastewater disposal. Effective FOG. Wastewater treatment involves a series of processes designed to remove or reduce the presence of these contaminants before the water is discharged into sewer systems or recycled. The common methods and technologies used in treating restaurant fat, oil and grease, wastewater will now be discussed. These are commonly known as source control and best management practices, BMPs. Grease traps, interceptors. Installed in kitchen drains, grease traps or grease interceptors are designed to capture fog before it enters the sewer system. They work by allowing wastewater to cool, which causes the grease and fat to float to the surface while solids settle at the bottom. The grease is retained in the trap and must be cleaned out regularly. When using pure sand BO blocks, your evacuation cycle will be 3 times longer, thus saving on operational costs. Proper disposal. Staff should be trained to dispose of fat, oil and grease in designated containers instead of pouring them down the drain. Scraping plates and equipment. Removing food particles and excess grease from utensils, plates and cookware before washing helps minimize fog. Content in the wastewater. 2. Primary treatment methods. Sedimentation. In this process, the wastewater is allowed to stand in tanks where the heavier, solid particles settle to the bottom, and lighter fog. Substances float to the top. This separated fog can then be collected and disposed of properly. Skimming. Skimmers are used to mechanically remove the floating fog from the surface of the wastewater. 3. Biological treatment, bioremediation. Bioaugmentation. Our pure sand bio blocks contains bacteria that produce enzymes that are introduced into grease traps or wastewater treatment systems to break down FOG into less harmful substances. Specific microorganisms can metabolize fat, oil and grease, converting them into water and carbon dioxide, reducing the overall load of FOG in the water. The added bacteria continue biodegrading fat, oil and grease downstream. 4. Chemical treatment is an expensive way to treat fat, oil and grease and causes further pollution of the wastewater that eventually becomes a problem for the municipality wastewater treatment plant and is therefore not recommended. 5. Physical separation methods are normally only used in large-scale fog, producing plants such as dairies and milkeries. Dissolved air flotation, DF. This technology injects air into the wastewater, forming small bubbles that attach to the fog particles. The buoyant bubbles carry the fog to the surface where it can be skimmed off. DAF is one of the most effective methods for removing suspended grease and oil from wastewater. Centrifugation. In some cases, a centrifuge is used to spin the wastewater at high speeds, forcing the denser components, such as water, to move outward, while lighter oils and fats are concentrated in the center, where they can be removed. 6. Advanced filtration technologies. Membrane filtration. Membrane technologies such as ultrafiltration or nanofiltration can be used to separate oils and fats from wastewater. These methods involve passing the wastewater through fine membranes that allow water to pass but block larger oil and grease molecules. Oil-water separators. These systems are designed to separate immiscible fats, oils and greases from water using gravity. Oil-water separators are typically installed in industrial or commercial settings, including large restaurants. 7. Sludge treatment and disposal. The separated fat, oil and grease and solids from traps, interceptors or flotation processes form a sludge that must be disposed of. This can be treated further through dewatering. To reduce the volume and weight of the waste, water is removed from the sludge, leaving a semi-solid material. Composting. Some facilities turn grease sludge into compost depending on local regulations and available technology. Rendering grease can be sent to rendering plants where it is processed into biofuels or other byproducts. 8. Effluent polishing. After the primary and secondary treatment steps, Polishing methods may be applied to ensure the final effluent meets environmental standards for discharge. Activated carbon filtration. This is used to remove any remaining organic compounds, including trace amounts of fat, oil, and grease. Disinfection using pure sand BWT bulk water treatment. A non-chlorine complex ionic solution may be required for further treatment of the wastewater before discharge. The pure sand BWT ensures that the water is free of all known waterborne pathogens and safe for discharge into the environment. Treating your fat, oil, and grease wastewater with pure sand environmentally positive products will give you peace of mind, as that is doing the right thing for the environment, water security for people, animals, and plants. In conclusion, I would recommend that in managing and treating FOG, in-restaurant wastewater protects plumbing infrastructure and reduces environmental pollution. A combination of source control, grease traps, biological, chemical, and physical treatment methods, along with proper sludge disposal, forms a comprehensive approach to handling restaurant fat, oil, and grease wastewater. For further information, please contact African Packaging and Water Solutions or info@apws.co.za or visit our website at www.puresand.net. We are standing by to take your call. Thank you for watching. We are